Good morning, CP Pre-Calc. Now what we're going to do today is we're still going to continue solving trig equations, all right guys? But we're going to add a different type of trig equation to the picture. What we're going to be doing is we're going to be solving trig equations using factoring. Now we're going to still solve them on the same interval, meaning we're looking for theta values between 0 and 2 pi, all right? But what we're going to have to do this time is we're going to have to take our knowledge of factoring out a common trig function to help us solve some of these problems. So the first problem I'm going to show you is sine theta tangent theta minus sine theta. Now we factored when we were solving trig identities. So we're going to use that same type of concept right now. So for example, number 1 here, you have sine theta times tangent theta minus sine theta is equivalent to 0. I'm going to take a look at this and say, do I have a GCF? And in this case, yes, I do have a GCF. Both terms have a sine theta. Now remember, when I factor out a sine theta, factoring is the opposite of distribution. So instead of multiplying, we're going to be dividing the terms. So that means I'm taking my sine theta tangent theta and dividing it by sine theta. That's what happens when I factor out that sine theta. So since I'm factoring it out, I'm dividing the terms. Minus sine theta, I'm factoring out a sine theta, that means I'm dividing by sine theta. Everything gets divided by the value that I'm factoring out. And what you'll notice then is here the signs cancel out and here the signs cancel out. So if I simplify everything inside, I'm getting sine theta times the quantity, tangent theta, and when everything cancels out, what am I left with? I'm left with 1. 1 is a factor of everything. So now what I have is I have sine theta times the quantity, tangent theta minus 1. Now when we have two things, when we multiply them together and they're equivalent to 0, we're going to use our zero product property that states one of them, in order for the product to be 0, one of them has to be 0. So we set both of them equivalent to 0 and solve. So we should have two solutions. If sine theta is equivalent to 0, the product would be 0. If tan theta minus 1 is equivalent to 0, the product would also be 0. So we're going to have two solutions here. Once I get here, I do the same thing that I've been doing the past couple days. I ask myself, sine theta. Okay, well, let's recall. We remember sine theta is y, cosine theta is x, and tangent theta is y over x. So we recall this. Now, when we take a look at this, guys, I got everything. I want to know when sine theta is equivalent to 0. Well, that's my y value. Go to your unit circle. And on one revolution, and I know it's one revolution because it's between 0 and 2 pi, inclusive of 0, non-inclusive of 2 pi, I'm going to start here and say, when is my y value equivalent to 0? Well, right off the bat, the first one would be at the radian measure of 0. So I know here theta is equivalent to 0. So here I'd say theta is 0. And then I look again, keep going. One revolution. When is my y value equivalent to 0? Right here at pi. So those would be two solutions. All right. Now let's take a look at my second one. Tangent of theta minus 1 is 0. I can solve this. Tangent of theta would be equivalent to 1. Now let's recall, look at that unit circle. When is tangent positive? This is telling me my tangent theta is equivalent to positive 1. Well, if I think all students take calc, tangent is positive in quadrant 1 and quadrant 3. So let's look. What is tangent? Tangent is y over x. Now, if this is going to be equivalent to 1, that means your y values, your y and your x values have to be exactly the same, because anything over itself will reduce to 1. So if I know tangent is positive in 1 and 3, I'm going to look in quadrants 1 and 3 and ask myself, when are my x and y values exactly the same? And when I look here, I go to quadrant 1, x and y are exactly the same at pi over 4. So that is one of my solutions. When else are they exactly the same? Well, I know tangent is positive in quadrant 3. So I look here, when is it exactly the same? Negative root 2 over 2, negative root 2 over 2. That's at 5 pi over 4. So you're going to take those 4 solutions and put them down here because all 4 of them can be solutions to my original equation. that's number 1.
All right, guys?
Now, let's try another one. Let's take a look at 2. Now, you might have an example in which you have 2 cosine squared theta is equivalent to the square root of 3 times cosine theta. Now, in an example like this, I want to emphasize you cannot divide by a trig function. If you divide by a cosine, you're going to eliminate one of your solutions that would end up working in the original problem. So, be aware that when you see a square, we need to solve it we need to solve it just like we would solve a quadratic equation. Meaning, when we solve a quadratic equation, we get everything set equivalent to 0. So this same concept will apply here when I have a trig function squared. So what I'm going to do is I'm going to get this set equivalent to 0 by moving the root 3 cosine. That's a positive root 3 cosine. I'm going to subtract it to bring it to the other side. And then it would be equivalent to 0. So when we move everything to one side, we either add or subtract. In this case, when we move terms to one side. When we move terms to one side, we're going to add or subtract. Now I get here and I say, do I have a GCF? Do I have a common factor? And I do. I have a common cosine theta. All right? So I can factor out that common cosine theta. And remember, when we factor it out, you're actually dividing each term by that value because factoring is the opposite of distribution. So I have a 2 here. Cosine squared theta, taking out one of the cosines, mean dividing it by it, I'm left with 1 cosine theta. Minus. If I take cosine theta and I divide it by cosine theta, that will cancel out. So I'm just left with that radical 3. Square root of 3 is equivalent to 0. Now we're going to do the same exact thing we did up here. We're going to break this down. I'm going to say cosine theta equals 0 and 2 cosine theta minus root 3 is equivalent to 0. So I'm going to set both of those terms equivalent to 0 because their product is 0. And the 0 product property states that if the product of 2 values is 0, one or both of them would have to be 0. So now let's take a look at the theta values that would give me a product of 0 here. Right, this one I have cosine theta is equivalent to 0. Now remember, cosine of theta is x. So I'm looking at my unit circle. I'm doing one revolution and I'm asking myself, when is my x value equivalent to 0? So I'm taking this here and I'm saying, when is x 0? Go around, when is x 0? It's 0 at pi over 2. All right, that's my first one. Let's keep on finishing that one revolution. When is x 0? It's 0 at 3 pi over 2. So there are 2 cases where my x value would be equivalent to 0, and that would give me my 2 theta radian measures. Okay, let's go over here. Now, here I have to actually solve for cosine first. So the first thing I'm going to do is add that radical 3. So I'm going to have 2 cosine theta equals the square root of 3. Then I'm going to divide by that 2. So now I'm getting cosine theta to be equivalent to the square root of 3 over 2. So I have a positive root 3 over 2. So I'm asking, when is x square root of 3 over 2? Now, since cosine is positive, I know that it has to be in quadrant 1, where everything's positive, and quadrant 4, where cosine is positive. So now I'm just looking, when is my x value equivalent to root 3 over 2? And I look and I say, okay, well, right here at pi over 6, I see x is root 3 over 2. And right here, I have a root 3 over 2 for x at 11 pi over 6. So now these 4, I write together, 1, 2, 3, 4, would be the 4 solutions to my equation on the interval from 0 to 2 pi.
Very good.
Okay, guys, let's take a look at what we're going to do next. We're going to do some factoring. So if I take a look, we're going to do something with a little more factoring. So let me just clear that up. Okay, our third example is going to look a little different because we are going to have
something that's in, again,
in quadratic form, except
it's going to have 3 terms.
so we can't just factor out a GCF in this case. Now, I can't factor out a GCF because my GCF is 1. I have 3 terms, and my GCF is 1. So I'm actually going to treat this like a trinomial quadratic equation. And when we have a trinomial quadratic equation, we factor. Now, in this case, let's take a look. If I look at this, my a value, remember our trinomial factor, we have ax squared plus bx plus c equals 0. And then we solve that by factoring. Now, in this case, my a value is 1. And when your a value is 1, we can use our basic factoring method, where we say what adds to 2 and multiplies to 1. Remember? So I'm saying what adds to 2 and multiplies to 1. Now, when we take a look at that and we think of our two numbers, in this case, it's 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. The only difference, and we went over this prior when we were doing our trig identities, is instead of having an x and an x in our two binomials, we're going to have a cosine theta and a cosine theta. And our two values, we said 1 plus 1 equals 2, check. 1 times 1 equals 1, check. Or be plus 1 and plus 1. And this would be equivalent to 0.
Now, if I take a look
Look at this. I know then I would say using my zero product property, cosine theta plus 1 equals 0. And again, cosine theta plus 1 equals 0. And guys, they're the same exact thing. So in this case, we're just looking for when cosine theta is equivalent to negative 1. In both cases, they're the same thing. So I'm looking for just when is cosine equivalent to negative 1. Now, cosine is our x value. So we're looking at 1 revolution on our unit circle. When is x equivalent to negative 1? And if we look at 1 revolution, the only time x is equivalent to negative 1 would be right here, and our radian measure is pi. So for both cases, theta would be pi. So we only have one answer here, guys. So you can really just write theta is equivalent to pi. All right? We're not going to worry about multiplicities or anything like that. You can just write theta is equivalent to pi.
All right, so now,
In this case, I gave you everything on one side. You might encounter a problem that looks like this. You might have 3 sine theta plus 1 equals negative 2 sine squared theta. Now again, we know it's a quadratic because we see a sine squared. And we have two terms with signs that are they're unlike terms. So I have a sine squared and a sine. Again, any type of problem that's in quadratic form, we need to set it equivalent to 0. So I'm going to take this negative 2 sine squared theta and I'm going to add it to the other side to get 2 sine squared theta plus 3 sine theta plus 1, it's going to be equivalent to 0. Now this one is slightly different because a is not 1. In this case, we have an a value. Our a value is 2. So we need to still factor this the same way we would factor a quadratic, like ax squared plus bx plus c is equivalent to 0. The only difference is instead of our x's, we have sine theta. So our method, you guys like to do it, 2 times 1 is 2. And then we say what? If I look at this one, we're going to say what adds to 3 and multiplies to 2. And what are our values? What adds to 3 and multiplies to 2? We know it's 2 times 1 is 2. 2 plus 1 is equivalent to 3. The only difference is because a is not equivalent to 1, how we have to factor this is we break this 3 sine theta up into 2 sine theta plus 1 sine theta. And then we bring down our first and our last terms. 2 sine squared theta plus 2 sine theta, and I got a plus 1 at the end. Once we get here, we factor by grouping. So I group my first 2 together, and I group my second 2 together, and I factor out the GCF of each group. Now, if I look at that first group, my GCF will be a 2 sine theta. If If I factor out a 2 sine theta, I divide every term in that group by 2 sine theta. If I divide 2 sine squared theta by 2 sine theta, I'm left with a sine theta. If I divide 2 sine theta by 2 sine theta, that cancels out to 1. Now, in factor by grouping, even if your GCF is 1, you still must show factoring out that 1. So in the second one, sine theta and 1, my GCF is 1. I have to show it. In factor by grouping, you have to show the factoring out of a 1. What remains? Sine theta plus 1. Now, inside my parentheses, I have the same common binomial factor. So I can pull that common binomial factor out. And I get sine theta plus 1 times the quantity, what remains? 2 sine theta plus 1 equals 0. Again, let's use that zero product property. Let's set them both equivalent to 0. So I have sine theta plus 1 equals 0 and 2 sine theta plus 1 equals 0. And let's solve. Here I'm going to bring over a negative 1. Here I'm going to bring over the 1, becomes a negative 1, and then divide by 2. So I have negative 1/2. So now I'm looking. Sine of theta has to be negative 1 and negative 1/2. We're looking on one revolution on our unit circle. Now, sine is y, so I'm going around one revolution and looking for the y value. So let's go around. Now it starts here. Sine is y. I'm looking for these values. Here I got all my y's are positive, so up. Here I got so we got all our y's are positive, right? Now I get down here. I got a negative 1/2. That is one of my y's, so that's my, right here, that's a 7 pi over 6. Keep going. I see a negative 1 at here for my 3 pi over 2. Keep going. I see a negative 1/2 as a y at 11 pi over 6. So I hit one revolution. I got all my answers. And for this solution, there are 3. So if I write this out, I have 3 pi over 2, 7 pi over 6, and 11 pi over 6 are the solutions to my trigonometric equation.
All right.
Not bad, guys.
All right. So those are
4 problems that we worked on. You have a couple practice problems below in a PDF. I would like you to please try them tonight. I think there's 4 of them. And post your answers just so I can see how you guys handled the lesson. If you have any questions, I would like you to come to my office hours. I'm going to be now doing my office hours on Google Meet. I find it might be a little easier for everyone. Certain people have said they've had difficulty with Canvas Conference. So I will be sending out a link through an announcement on Canvas. So we will be doing a Google Meet for office hours, and I will post the link on an announcement on Canvas. It will be the same time as my normal office hours. I hope you guys have a great day, and I hope to see you on Google Meet.